Hi, my name is Marwan. I'm a technical developer advocate at Nebius, and today I'm going to show you how the platform is structured and how everything fits together. We'll start with the login page and then walk through the home dashboard, look at how projects and regions define your environment, and finally explore the core services: compute, storage, AI services, applications, and administrative section. Let's go. Before working with any cloud resources, the first step is signing in. Here on the login page, you can authenticate using Google, GitHub, Microsoft, or your organization's SSR. This allows individual developers to get started very quickly, while enterprises can integrate with their existing identity systems. Here, I will log out using my SSR account. Once inside, this is the home dashboard. At the center, you'll see my resources. This section gives you a live overview of everything running inside your current project. As you create virtual machines, storage buckets, clusters, or AI workloads, they will appear here. Below is the features section, where you'll see common starting points, such as Kubernetes clusters, Skypilot, or Ray clusters. These represent typical compute and AI usage patterns. Further down, the workload section. The workload section provides direct access to running and distributed jobs and tasks. Think of the home dashboard as the operational overview and quick access layer. Now, let's look at how your environment is scoped. At the top of the console, you'll see the project selector. Projects act as isolation boundaries. They allow you to separate environments, teams, or workloads. For example, you might run experimentation in one project and production systems in another. Switching between projects changes the entire resource context. Every resource you create belongs to a specific project. Next to the project selector is the region. Regions define the physical location where your infrastructure runs. Resource availability and quotas are region specific, so the selected region determines where your workloads are actually deployed. Every resource in Nebius Cloud is scoped by both a project and a region. So with this structure in mind, let's explore the services. Let's start an open compute. This is where the infrastructure layer lives. Here, you can create virtual machines, for example, which allows you to provision CPU or GPU instances with full control over configuration, storage, networking, and access. Virtual machines are the most flexible built-in block in the platform. But if you need to run distributed workloads, you can use Operator. Operator provides managed Slurm clusters designed for high performance and multi-node training. So instead of manually configuring and connecting several machines, Operator handles the cluster orchestration for you. And for container-based workloads, Kubernetes offers a managed control plane for orchestration. You can, using Kubernetes, create clusters, configure GPU-enabled node groups, and deploy scalable containerized applications. Together, all these services give you direct access to the infrastructure layer of Nebius Cloud. Now, let's have a look at storage. Here, you'll find object storage, shared file systems, and other persistent storage options. Object storage is commonly used for datasets, model checkpoints, logs, artifacts, and so on. Shared file systems, on the other hand, allow multiple machines to access the same storage simultaneously. Storage underpins nearly every workload in the platform. Next, let's go and open AI services. This section provides higher-level services built on top of infrastructure so you can focus directly on your AI workflows. Start with jobs. Jobs allow you to run training, fine-tuning, and match workloads without manually provisioning virtual machines. You define the workload, select the resources, and then you submit it. Then we have endpoint. Endpoints lets you deploy models for real-time inference and expose them as APIs, turning trained model into production services. You'll also see MLflow, which supports experiment tracking and model management. Ray provides a distributed framework for scaling Python workloads, and Skypilot helps manage larger distributed AI jobs more efficiently. So bear in mind, if compute is infrastructure first, AI services are workflow first. Next, let's go and open applications. Applications is where you can deploy prepackaged tools and frameworks. So instead of configuring everything from scratch, you can launch ready-to-use environments in just few steps. Applications help reduce setup time and accelerate common workflows. And just below that, there is the Manage section. This is where you handle visibility and control across your environment. In billing, you can review usage and monitor costs. And in administration in audit logs, you can track activity across your organization, and you manage access and permissions in identity and access management. While other sections focus on running workloads, this area ensures your environment stays organized, secure, and accountable. What you've just seen is the foundation of Nebius Cloud. Projects and regions define your environment, infrastructure services give you control and flexibility, AI services let you train, fine-tune, and deploy models without managing any underlying complexity. Applications help you move faster with ready-to-run tools. And last but not least, the administrative layer ensures visibility, governance, and cost awareness across your organization. All of it is designed to support the full lifecycle of modern AI workloads, from experimentation to production. And now that you understand how everything fits together, you're ready to start building with confidence.